about the PMOS transistor, which are nothing but P-type enhancement metal oxide semiconductor field effect transistors. That is P-type enhancement MOSFETs. Okay, you know enhancement MOSFETs, right? When I talk about enhancement MOSFETs, there are no channels. Okay, in an enhancement MOSFET there is no channel. That's why in the previous video you would have looked at the NMOS. There is no channel. We applied a voltage called as VGS, and which will attract the negative charges from the substrate, and it will make the channel, right? Then if you apply VDS, the conduction will happen. Here also the same case. There is PMOS, whose symbol, before drawing the symbol, let me draw the cross section of PMOS, where you will have the P plus active regions. Okay, then this is nothing but an N substrate, right? And there is a gate here. Actually speaking, we should draw it in a neat manner. So let me draw it again. Okay. So this is a P plus region. This is nothing but the drain. There is another P plus called source, and the substrate is actually an N-type substrate. For a PMOS, you have to use N-type substrates because you have to attract the positive charges. For NMOS, you have to form P-type substrate, right? And this is the gate terminal. Okay. Here the difference is what you have to note from NMOS is this is a PMOS structure, right? So here in the gate terminal, you have to apply a negative voltage. Okay, you have to apply a negative voltage. So if you apply a negative voltage, let us say -1, -2, -3 and so on, you have to apply negative voltages. Why negative voltages? Negative voltage will attract positive charges, because we know that opposite poles will get attracted. So negative voltage will attract positive charges. So when you get positive charges here, you can form a P channel, which is required for a PMOS. You can form a P channel, which is required for PMOS. So here also gate source voltage should be applied, but you have to apply a negative voltage. Voltages in negative signs, then only it will attract the P charges, that is positive charges, and you can form a P channel between drain and source. Here you are seeing that drain and source are active regions of P type, right? So you have to form a P channel only, then only the channel will be formed and the current can flow, otherwise the current will not flow, right? So VGS has to be negative, that has to be noted down. So if VGS has to be negative means what? It should be at logic 0, right? Let us take all the negative to be logic 0, right? So for a PMOS whose circuit looks like this, if you apply 0, there is again an inverter type so bubble here, this comes with the circuit. If you apply 0, the transistor will be on, remember. For an NMOS, if you apply 1, the transistor will be on. For a PMOS, if you apply 0, the transistor will be on. That is very important. What if you apply 1? If you apply 1, that means you are applying a positive voltage, right? If you are applying 1 means you are applying a positive voltage, right? If you are applying a positive voltage, positive charges will not get attracted. They will be repelled, correct? Because like charges repel each other. So if you apply a positive voltage, positive charges will not be attracted. They will be repelled. I mean, they will be getting back. You will be attracting the negative charges, right? So that won't form a P channel, right? Again, the transistor will be off. The conduction will not happen. Okay, so the conclusion or the summary is NMOS transistor will look like this. PMOS, okay, let me draw true NMOS and two PMOS. Okay. PMOS transistor means you have to put a bubble and show it. Okay. For an NMOS transistor, this is gate, drain, source. If you apply 1 to the gate, transistor will be on. Again for an NMOS transistor, if you apply 0 to the gate, transistor will be off. This is drain and this is source. Okay. And one more thing to be noted here is drain should be pulled up, source should be pulled down. Okay, so drain should be connected to VDD, source should be connected to ground. So drain should be pulled up and source should be grounded. That is the current flow from drain to source. Here in PMOS, again, if you want to make the transistor working or on, you have to apply 0 to the gate. Then only the transistor will be on. Okay, and here source should be pulled up and drain should be grounded. This has to be noted down. Very, very important, guys. For a PMOS, source should be pulled up and drain should be grounded always. Drain should be pulled down, right? And if you apply 1 to a gate of a PMOS, it won't be active. You know that it won't attract the positive charges, so it will be in off state. Okay, so this is the conclusion on what we have discussed so far, and using these ideas we'll be able to design the VLSI circuits. It is enough if you understood these, and if you want to learn more, you have to go back and study some courses on MOSFETs to understand this a lot. Thanks a lot.